Hello dear participants of this course. I welcome to lecture 8. In this lecture, we will discuss about crop coefficient and crop water requirement. In previous lectures 6, 7, we discussed about evapotranspiration and we estimated evapotranspiration by using reference crop evapotranspiration and crop coefficient. Whereas, we were estimating reference evapotranspiration and multiplying with the crop coefficient to determine actual crop evapotranspiration. But sometime when we are using lysimeter or we are using FAO 56 method, and in lysimeter if we have grown a reference crop where we are maintaining ideal condition, means there is no deficiency in soil moisture content when it is covering the entire ground and it is grown with grass. So, whatever amount of water it is evapotranspired by the grass or reference crop is E T naught, and actual evapotranspiration of the crop in another lysimeter in the adjacent condition is maintained. So, one can get the crop coefficient value by using the actual evapotranspiration of the given crop divided by the reference evapotranspiration, reference crop evapotranspiration or potential evapotranspiration. So, one can get crop coefficient value. Now, we will discuss in detail in this lecture 8 about crop coefficient. Now, in this particular lecture we will discuss about single crop coefficient, which is which has been in majority of the literature it is being used single crop coefficient. Dual crop coefficient very limited work or limited information is available, but particularly for micro irrigation this is very relevant. So, let us try to know what is a dual crop coefficient and how it can be utilized and how it can be determined. Water requirement of crop, different crops is another important thing for irrigation planning. So, we will be discussing about water requirement of different crops. So, let us know what is the crop coefficient. So, crop coefficient it is the when we are calculating ETC, that is crop evapotranspiration, we are multiplying reference crop evapotranspiration with Kc, it gives the value of actual crop evapotranspiration. Now, ET naught is a grass, means a reference crop, means it is the crop which is used as the or it is the reference crop which is used as a ideal crop, where ideal situations well water condition is maintained when the this particular crop water is from the atmosphere, the demand of the atmosphere, the energy provided by the atmosphere, it is used, it is providing the energy for evapotranspiration. So, the amount of water evapotranspired by the reference crop is E T naught, and this E T naught when we multiply it with the Kc factor or crop coefficient, it gives the actual evapotranspiration of the crop. So, Kc is one need to determine what is the Kc value. Now, why crop coefficient approach is important? It is not represent index of climatic demand, means a reference evapotranspiration is basically it is influenced by the atmospheric parameter. Kc varies predominantly with the crop characteristics. So, Et naught climatic demand and then the crop characteristics means it is the Kc it is influenced by the crop characteristics. It is a limited to a certain extent, it is only limited with the climatic, means there is a means not much influence of the climate it is there, but the mainly it is the crop characteristics, and this enables the transfer of standard values of the crop coefficient between location and climate. So, means a particular place where the crop is being grown and then what is the climatic situation it exists, this makes the change in the value of the crop coefficient. And this is the primary reason the global acceptance and usefulness of the crop coefficient approach has been considered to determine the actual crop evapotranspiration. Crop coefficient is basically ratio of actual crop evapotranspiration, which we call it as a ETC, to the reference evapotranspiration. It is the ratio of ETC to the Et naught, and it represents the integration of 4 primary characteristics. What are those 4 primary characteristics? One is crop height, another one is albedo, another crop canopy resistance and soil evaporation. So, that distinguishes the typical field crop from a reference crop. So, means crop characteristics are incorporated in the determination of Kc, or it is incorporated in these 4 parameters. So, different crops have different Kc values, and changing the characteristics of the crop over growing season also affect the Kc value. As evaporation is integrated part of evapotranspiration, condition affecting soil evaporation means condition here that what is the moisture content of the soil, whether it is a plowed soil, whether it is a old soil where it is already it is a labeled. So, this influence the Kc value. Now, the factors which influence the crop coefficient, here we can see Kc at the mid season stage, and the crop you can see here some crops like pineapple, peaches, cotton. So, and some grass reference, means this is a reference crop as a grass. So, crops which are falling, means you can say pineapple, peaches, cherries, apple, here crop coefficient at the mid season stage is less than the means reference grass reference crop, and crops which are greater than 1, means Kc value at the mid season is greater than 1, it is cotton, some of the vegetable crops, and then large vegetable crops and sugar cane. So, crop type it influence the crop coefficient value. So, due to why it is so, due to difference in the albedo, means reflectance characteristics of the crop, it influence the crop coefficient value. Crop height, aerodynamic property, means the leaves and then the canopy structure, the shape of the leaf. This also influence the value of crop coefficient. Stomata property, the evapotranspiration from fully grown area, well watered crop differs from ET0. So, the crop type is one part. Then spacing between the plants, how close they are, how means spaced they are, and then the taller canopy height and roughness of many fully grown agricultural cause these crops to have Kc factor larger than 1. This is what we see these crops which have got more than the Kc value greater than 1. Climate does influence. So, it is the wind. So, aerodynamic property between the grass reference surface and agriculture crop is not only crop specific, but this also affect. It also varies with the climatic condition and crop height, because aerodynamic properties are greater for many agricultural crops compared to grass reference. As we are giving here ETC means Kc is the ratio of ETC to ET0. So, for many crops the value of Kc it increases as the wind speed increases and decreases when the R means with the decrease in the relative humidity. So, Kc value means for more arid regions and conditions of having greater wind speed has got higher Kc value. More humid climate and conditions of lower wind speed have got lower Kc value. So, this influence. Now, we can see from this particular figure. In this figure, we can see here the Kc values are ranged from 0.8 to here it is given range is given 0.8 to 1.5. So, for salt crops, if we see salt crops like cabbage, onion, the Kc value range is in case of very humid condition, for very humid condition when we are putting the Kc value is less than 1.1, or in some cases it goes up to maximum means less than 1.2 rather we can say. And when we go for the crops which are the characteristic is taller comes in the taller crop range, say cotton, maize or sugarcane, and particularly for extremely arid and wind condition, then what we find the Kc value it goes high. So, the statement which I gave for a low wind speed and very humid condition, the value of Kc is lower as compared to the taller crops and arid and windy conditions. That is what one can see from this particular graph. So, the means Kc is influenced by climate and weather condition and also the type of crop characteristics, salt crops or large crop. Soil evaporation. Now, this also influence the crop coefficient value. So, difference in soil evaporation and crop transpiration between field crops and reference surface are integrated within the crop coefficient. Let us see here it is a plotted Kc value on ordinate and then plant the growth plant growth characteristic it is plotted on abscissa on x axis. Now, what we see here, this is in the early stage means it is in a seedling stage, and as the plant grows. So, means initially what we see, there are 2 leaves, then 4 leaves, and then as the plant grows, means it start covering the ground cover, means canopy growth development is causing the covering the ground. So, at initial stage, let us say the soil is in a typical dry soil characteristics, it is shown here. So, soil evaporation is dominant, soil evaporation will be dominant in the initial growth stage of the crop or seedling stage, and when it goes toward the growth of the crop, it start covering the ground cover. So, what we see, transpiration of the crop is more dominant, which we call it as a basal crop coefficient, where transpiration is dominant. So, value of the soil evaporation coefficient at the beginning stage is more. Now, this is one case when dry soil exists, and means a dry condition of soil surface exists, and this is the wet surface when you are giving enough moisture is being maintained or irrigation is being given. So, horizontal line here it represent Kc value when soil surface is kept continuously wet or irrigation is being maintained all throughout. Curved line, this is the line which dotted line which we see. So, curved line corresponds to the Kc when the surface is kept dry, but crop receives sufficient water to sustain transpiration, means that much amount of moisture is maintained where crop is can be able to maintain the transpiration, but the value of crop coefficient we can see here, it is closer to 0.1, and when it is in wet condition, when we are maintaining this, then crop coefficient value is more than 1. So, here the for wet soil condition, Kc value may exceed to the to 1, or and for dry soil condition, Kc is small, as low as 0.1. So, the soil surface, what is the condition of the moisture content in the soil, this also causes the Kc influence on the Kc value. Now, let us see the another aspect of the crop coefficient. So, we let us see on this part. Just now I told you that when the crop is means let us say the crop at the initial stage, few weeks, say when the crop is just it has emerged, leaves have emerged. So, this stage is called as the initial stage. Now, crop starts it's a leaves and it start development stage. So, for few weeks, let us say that it is it behaves like this is a development stage. Crop development stage means ground cover plant development. So, as the number of leaves it increases, say vegetable crop or any other crop, it start covering the ground. So, what we are seeing, for few days it is covering 25% of the ground, then 40% of the ground cover, and then 60%. So, it goes to a particular, it has reached to a stage when the development it has taken place fully, and then it comes to the mid season stage, we call it as a maturity stage. Crop has got full maturity stage, that is a mid season stage, and then it comes to the end stage. So, total crop growth stages can be divided in 4 stages: initial stage, crop development stage, mid season stage, or and late season stage. Okay. Now, in the means when the crop has covered the fully ground, and then it is in the full fully grown plant, and it starts emerging flowers, and then it started giving fruits. Now, here The another part it is being shown the same crop when we are giving maintaining some certain irrigation interval. So, if we are giving a very short interval frequent irrigation. So, this is a wet condition is being maintained and this is slightly the dry condition means partial moisture condition or certain we can say soil moisture deficit is being maintained. So, it influence the crop coefficient value. So, this graph when we see this is the nature of the graph when we are maintaining certain the soil moisture deficiency, and whereas here what we see when we are giving frequent irrigation. So, particularly we can say in case of micro irrigation system we are not maintaining deficit condition, we are exactly maintaining ideal condition where the crop does not have to go for any stress moisture stress. So, this is more relevant for micro irrigation condition. Now, the Kc value when the deficit is being maintained at initial stage, we find that it is more or less it is maintaining means little slightly more than 0.2, and when for the same initial stage we are getting almost it is equal to 1 or more than 1 in the initial means where the in the initial stage soil evaporation component is predominant, and then when it comes to the crop development stage, the nature of graph you can see here there is a considerable change in the value, and then when it is a crop humidity or wind is being maintained, then this is the nature. Now, we can there are variety of crop which is being shown. So, lower the value of Kc value for short height crops say cabbage, onion or apples as compared to the sugarcane, cotton or maize crop. Now, for the crop harvesting stage or in drying stage, the Kc value it reduces drastically. So, these 4 stages crop growth stages are influencing the Kc value, and this Kc value is influenced by the soil moisture condition and then the type of crop. So, as it is explained here as the crop develops, ground cover, crop height and leaf area change means leaf area index changes. Due to differences in evapotranspiration during various growth stages, Kc for a given crop will vary over growing period, and at the mid season stage, that is the part that stage Kc reaches to the maximum value. So, maximum value when there is a infrequent irrigation is being given, when frequent irrigation is being given, that value is there, but it reaches to a peak value of the Kc, and Kc value at the end or the late season stage reflect the reflect crop and water management practices, how the water management, how the irrigation is being given, whether irrigation is being given by micro irrigation, it is being given by surface irrigation or it is being given by sprinkler irrigation. Now, here we will be discussing about single crop coefficient approach, where only Kc value is used, whether Kc is combined. So, let us know that what single crop coefficient it means, and that is in the majority of literature you may find that the single crop coefficient approach has been used. Now, in single crop coefficient approach, the effect of crop transpiration and soil evaporation, these two components are combined, means it involves the Ke and the crop transpiration, that is a Kcb. So, both are actually combined in single crop coefficient. The coefficient integrate difference in soil evaporation and crop transpiration rate between crop and grass reference surface. So, as the single crop coefficient average soil evaporation and transpiration, the approach is used to compute ETC it is for a weekly or longer time period, although calculation may proceed on daily time step. So, here we are computing the evapotranspiration or by taking number of days. So, particularly for surface irrigation system or to a certain extent on weekly basis for sprinkler irrigation system, single crop coefficient approach is being used. In dual crop coefficient, the dual crop coefficient approach, effect of the crop transpiration, soil evaporation are determined separately. Two coefficients are used. One is basal crop coefficient, that is a KCB, to describe plant transpiration, and soil water evaporation coefficient, which we call it as a KE. So, here these two components are considered, and these two components are important. We have seen that at initial stage K is predominant, at the growing stage as well as the late season stage or mid season stage, KCB is predominant. So, the basal crop coefficient is defined at the ETC to ET naught, where soil surface layer is dry, but where average soil water content of the root zone is adequate to sustain full plant transpiration. The soil evaporation coefficient Ke describes the evaporation component from the soil surface. Now, it is the left side diagram. When we see, this is a generalized crop coefficient. So, left side diagram, this is a for single crop coefficient, means Kc initial. This is a typical graph, generalized crop coefficient graph, which we are seeing here. So, Kc initial, then Kc development, Kc mid season, and then Kc end season, means all 4 stages. A typical graph looks like this. It is a for a general. So, means it looks like this, whereas in a dual crop coefficient Ke and Kcb, these two components are shown. So, Ke, it means it is predominant, means the evaporation component is predominant at the initial growth stage, and then it started, the evaporation it starts slowly reducing. As the crop development takes place, it narrows down to a minimal value, that is the Ke component, it becomes lesser as compared to the Kcb, and then Ke means. So, in mid season and late season stage, Ke is lesser as compared to the initial initial crop growth stage. So, this is important when the crop is in the different growth stages, and one need to calculate while using. So, general selection criteria for the crop coefficient approach, it is used for when we are taking single crop coefficient, it is used for irrigation planning and design, it is used for irrigation management, it is used for non-frequent water application by giving irrigation through surface irrigation, means border irrigation, furrow irrigation or basin irrigation or sprinkler irrigation, where 10-day or monthly data means daily data are summed, and then one can irrigation is being given. Whereas, dual crop coefficient, it uses the real time irrigation scheduling data. It is used for frequent application of water like micro irrigation, automated sprinkler irrigation system, and detailed soil and hydrologic water balance. If someone wants to use the data, in that case your daily water balance. So, dual crop coefficient is more relevant for daily calculation. Now, let us come to crop water requirement. Crop water requirement, it is the total quantity of water required by a crop irrespective of its source in a given period of time for its full normal growth development under field condition at a given place. So, it includes amount of water to mature an adequately irrigated crop to meet the losses due to evapotranspiration plus losses during application of irrigation water. Means if it is a surface irrigation, there will be losses, that is the if it is a means border irrigation, if it is a check basin irrigation, there will be unavoidable losses. Additional quantity of water required for a special operation such as the land preparation, transplanting purpose. If soil is having salt, so we need to apply water for leaching of salts. So, below the crop root zone, there could be some situation where the frost control. So, this is a special need. So, total water required, that is added to get the irrigation water requirement. And now, typical water requirement values for the variety of crops, though it is given 1200 millimeter for rice, but it is used more than 1800 in some cases, but it depends on in which season the rice is being grown. So, value of crop water requirement from rice to your field crops, field cereal crops, vegetable crops, horticultural crops as well as vegetable crops. So, fruit crops, vegetable crops, all these crops which are available, and this is these values can be used as a reference value. Of course, these values will vary depending on the soil, depending on the particular variety of the crop, depending on the climatic condition where it is being grown, but this can be used as a reference value for a design of irrigation system. Net irrigation requirement, as the name it says that it is the total amount of water irrigation required to bring the soil moisture content in the root zone depth to field capacity. So, determining the moisture content difference at the field capacity and moisture content before irrigation, this difference at the different layers when we multiply with the bulk density of soil, multiplying with the depth of root zone, then one can get what is the net irrigation requirement. Now, the total soil profile, soil layer, it can be given made a several sampling it can be made. So, 4 layer, 3 layer, 5 layers, that depends. So, I refers to the number of soil layers, and then these value it can be used to find out the net irrigation requirement. And then to get the grass irrigation requirement. So, net irrigation requirement, after we have calculated, we need to divide this value with the overall irrigation efficiency. This will give the grass irrigation requirement. Now, with reference to surface irrigation as well as when we want to supply water in command area by using the canal irrigation water, there are some certain terminologies which are used, which are important from irrigation point of view. So, duty is one of the term which is commonly used, and duty it is means it defines that what is the amount of means the rate of flow per unit area. It can be given. So, it is area that can be irrigated by continuous non supply of irrigation water. So, rate of 1 cubic meter per second of water throughout the base period. This value is used and it is expressed in hectare per cubic meter per second. Base period is another term which is used. This is the period over which irrigation water is to be supplied for the production of any crop. Normally, this is equal to the period between first and last irrigation applied to a crop. Delta is another term. This defines the means the depth of water during crop season to be given to meet the crop water requirement, and this does not have any relevance to the area of the crop field. it is expressed in millimeter or centimeter. There is a relationship between duty delta and base period. So, delta means your depth of water can be related as equal to 864 multiplied by B by D. So, delta when we express in centimeter, base period when we express in days, and D when we express in hectare per cubic meter, then this is given by delta equal to 864 into B by D. So, now in this particular lecture we have let us summarize this particular. We have covered the concept of single and dual crop coefficient. We have discussed about crop water requirement and irrigation requirement terminologies, and we will be discussing about the different types of agrometeorological instrument used to determine evapotranspiration. So, we will demonstrate some of those equipment in coming class, and so that you can have the full knowledge how these equipment they are used for estimating the evapotranspiration, as well as other the field water balanced weight measurement. It is done for determining the measurement of evapotranspiration. So, these are the references which you can refer for your study. So, thank you very much and good day.